Hello everyone. Today I'm going to present you a technical demonstration of implementation of generative AI in a e-commerce website. Okay. So as you can see in your screen, you can see I have created a dummy e-commerce website. Okay. So where user can visit and search for the products, and also user can also we have a chat bot here. Okay, so user can also represent his or her query to the chatbot, and chatbot will reply according to user query. Okay, and also there are some features this chatbot has. Okay, so the first features is gathering customer information. Okay, so chatbot can gather customer information like email, mobile number, and name. And also chatbot can validate the provided customer information using WhatsApp OTP verification. Okay, so after providing all these details, customer will get a WhatsApp notification. Okay, with an OTP. Okay, and once customer provided this OTP, the chatbot will auto verify the customer. Okay, and the customer will be logged in automatically. Okay, so this is the third feature of this chatbot, that it can log in a customer automatically. Okay, so there is no login page or logout page, anything. Just customer can log in via the chatbot. Okay, so another feature of this chatbot is uh, like searching relevant products based on user query. Okay, so let's say someone search for a product this YOLO bioceramic bowl. Okay, so let's say someone searching for they are looking for ceramic bowl for their aquarium. Okay, under 180 rupees or something. Okay, so this chatbot will go to the database. Okay, so we have multiple database. Okay, so the first thing what chatbot will do, so once user search for a query. Okay, so first it will go for the Algolia. So here in this application we have implemented Algolia search. Okay, so it is kind of a elastic search type of feature. Okay, application which enable e-commerce website to search on vast amount of data, and provide almost a millisecond or uh, less than a millisecond latency, and it will give you a result. Okay, so this is the feature. Okay, so first it will first when a user search for a query, it will go to Algolia and check whether that query matches or Algolia return anything. Okay, so if Algolia does not return anything, okay, so Algolia is kind of like quite a basic thing. Okay, so it will search based on user input, like keyword matching, this type of thing. Algolia also have AI feature, but in this project I'm using free version of it. Okay, so those features are not available, so only keyword matching and this type of features are available. Okay, once if Algolia don't provide any relevant result, okay, so then what will happen? The query will go to our vector database. Okay, so here the RAG part of generative AI comes. It will go to our vector database. So we are using self-hosted quadrant vector database. Okay, so all these products are available in our vector database. Okay, so now the query will go to the vector database, and it will fetch the relevant query based on user result, based on user request to the customer. Okay, so this is the another feature of this chatbot. And another last feature of this chatbot is this chatbot can like query past user user orders. Okay, So user can ask for like what is the status for my order ID 1234. Okay, so and chatbot will call an API and get the status report of that order, and it will provide to the customer. Okay, so in this application, as you can see, only there are two way customer can interact with our GenAI implementation. Okay, so first one is here in the search. Okay, so now let me just show you in terms of user experience from the front end how the things look like. Okay, so first let me start with the basic search bar. Okay, so if we start typing anything in the search bar. Okay, so let's say we typed like what is it? Uh, let's say we type bioceramic ball. Okay, so so once we type these keywords. Okay, so what happen is this query directly goes to Algolia. Okay, and if Algolia is not able to cater the response. Okay, then it will go to our backend vector database quadrant which we are using, and it will fetch if any relevant products are available, and it will return. Okay, the information. Okay, so now as you can see, this is like basic search feature. Okay, so now let me start the chatbot. Okay, so now let me just show you the feature of a chatbot. Okay, and how this chatbot is able to answer user query. Okay, uh, uh, so let me just get back to the main part. Okay, so now as you can see here, we are logged in as a guest user. Okay, so there is so that means that this user does not have any kind of login information present with the account while they are surfing. Okay, so so now so here is our chatbot. Okay, so now let's say I'm typing like I like to buy bioceramic ball for my aquarium. Okay, okay. So so this chatbot is designed a way like first what it will do, it will get a user query. Okay, so let's say that now as you can see here, user is asking that he wants to buy a ceramic ball for his aquarium. Okay, so now what this chatbot will do, its first work is to get customer information. After getting customer's query, like what customer wants to do, it will ask for customer information. Okay, so in this step he is asking, as you can see, hello chatbot, it seems like you are looking for bioceramic ball for your aquarium. Before we proceed, I need to verify your account. Could you please provide your name, email, and 10-digit mobile number? Okay, so let's play with this chatbot. Okay, so let's say I'm saying my name is Abhijit. Okay, now hit enter. Okay, so now this chatbot is greeting me with thank you, Abhijit. Could you please also provide your email address and 10-digit mobile number? So until all this information, this name, email, and phone number is provided, and after providing this all this information, this chatbot will send me a OTP over WhatsApp, and I have to type this OTP in this chatbot, and after it will validate with my provided OTP, and once it is validated, it will auto log me in. It will auto log me into this application, okay, and it will provide me with this uh, product link, or like I asked for bioceramic ball filter media, it will send me this link, okay, to go. Mm. So let's type my email and mobile number. So as you can see, I've typed my email and mobile number in the same line, and this chatbot will auto detect this email ID and mobile number. Like we don't have to like provide any special type it like this is my mobile number, this is my email ID. It will auto detect based on his previous learning. Okay, so let me hit enter. So as you can see, I have sent an OTP to your mobile number via WhatsApp. Please provide the OTP to verify your account. Okay. So let me check my mobile number. So I got the OTP. It is 1111. Okay. So once we hit this 11111, it will verify. Okay, so now it is verified with the internal OTP and the OTP I have provided. Okay, and it gave me this link, this YOLO bioceramic ball filter media. As you can see, this is the link, this link, and this link. Let me just copy the link, and let me also copy this link address too. Okay. So as you can see, both of these links are same. Okay. So now what now how this happened, this flow happened. Okay. So after the validation, okay, this chatbot remembers. Okay. This chatbot remembers that what the customer query or intent was. The customer was asking for a ceramic ball for his aquarium uses. Okay. Bioceramic ball for his aquarium uses. Okay. So after the verification, the chatbot will first query the Algolia. What it will query? It will query that bioceramic ball for aquarium. So generally, this query does not return anything from the Algolia. Okay. So now what will happen? It will go to our vector database. Okay, and query our vector. It will uh, uh, go to our LLM, okay, and this information, this text, this bioceramic ball, this text will be converted into embedding, vector embedding, okay. So after this vector embedding is done, this that embedding will be passed to our quadrant vector database, and it will be matched. This vector database, this embedding will be matched with our vector database, and whatever information related to this query it found in our vector database, it will return. So as you can see here, we found two URL. Okay, so bioceramic ball for filter media, and another one is this one, this burnt red ceramic ring filter media. Okay, so these two are relevant products that it able to find in our quadrant vector database. Okay, and it returned. Okay, so this is it. So now I will in next part I will show you like the insight of the UI the insight of our like vector database, like how these products are like distributed among our 1536 dimension that we used like OpenAI LLM. Okay, so in our project, okay, so its dimension is 1536. So this embedding will search on it. So now let me show you another feature, the last feature that I told you, like it will this chatbot also can search for the user order status. Okay, so let me just demonstrate this feature too. Okay, so so here is the user that I am logged in with. Okay, so so if you go to this table, okay, in the customer table, you can see like this is my name, email, and mobile number. Okay, so this corresponding customer has this order. Okay, so this customer has this order. Okay, so so let me just try to query our chatbot and try to find if our chatbot is able to find this order for this user. Okay, so okay, sorry. So as you can see that now we are logged in after providing the OTP. We are logged in as a Abhijit Das account. Okay, so now let me just query our chatbot to find our order status. Okay, so let me. Okay, so so now after querying this, after we query this to our chatbot, okay, so what our chatbot did is that it knows our user ID. Okay, so as you can see in previous interaction, we have validated our account with the chatbot, and we are logged in now as Abhijit Das. Okay, and as I showed you in our DB that that we have this order ID. Okay, so so this chatbot will automatically search the recent order for this user. Okay, so as you can see that 22661. So this is our order ID. Okay, so this is our order ID, and the chatbot is successfully able to find this recent order status. Okay, so it's saying that your recent order ID is 226 on has been delivered. If you have any other question or need further assistance, just let me know. Okay, so in this example, I also showed you like how this chatbot is able to query our MySQL database via doing API call. Okay, so so this chatbot has like many capabilities as you can see here. Okay, so in the next part, I think I'll show you the quadrant database part where you can visualize that how these products are spread among the axis, how a particular product is close to a particular segment of product. Okay, so and how this is happening. Okay, and I will also provide a flow diagram that how this thing is communicating to other microservices. So now in this part, I'll show you that I'll show you the quadrant vector database, and also I'll show you the Algolia part, that how these products are added in the are present in the Algolia dashboard. Okay, and after that I'll show you the flowchart diagram of how things are happening here. Okay, so as you can see here, I have this EC2 instance, this T4G medium instance I have here. Okay, so in this instance I have installed our quadrant. Uh, I have installed our quadrant software here. Okay, so let me just log into our. So as you can see here, we have Quadrant vector database running in our EC2 instance here. Okay. So now let me also show you our Algolia dashboard here. Okay. So this is the Algolia dashboard. It is, as I told you before, that it is a kind of Elasticsearch feature. Okay. So as you can see that all the products that are present in our dummy website are available here. Okay. So first, whenever someone query for a product or query for a product, it comes for, first it hits the Algolia, because as Algolia response time is almost under a millisecond. Okay, so if the product is not found, like sometime what happen, people do really complex query, like people do like I want to buy this, like if you remember that we type this query. Okay, so let's say that we paste this query here, same thing. Let's say what happens, nothing comes. Okay, so so as I told you, Algolia is like a keyword matching thing. Okay, so this keyword, this query that we do, this query does not return any kind of result. So once this result gets empty from Algolia, okay, so then it, as I told you before, that it goes to our quadrant vector database and its query. This text will be converted into embedding, and those embedding will go to our quadrant vector database, and it will provide and it will perform the query in our quadrant database, and which I will show you after few moments, like how this information are present across present in our uh, quadrant vector database. Okay, so this Algolia does not return anything using this query. Okay, so now as you can see, this quadrant is installed in our EC2 instance. Okay, so to connect this instance from our local. Okay, so we have to create a tunnel. Okay, so I have created this script in our terminal. Okay, so now this uh, tunnel is created, and we can also access this quadrant from our local. Okay, because in local I have this quadrant web UI, okay, installed here. Okay, so let me just rerun it. Okay, so after running it, okay, it will give you a URL. Okay, so I have not installed this UI in our EC2. Okay, because it is already consuming most of its memory. Okay, so if I install this UI in my EC2, then I have to open another port. So it is like kind of extra extra. It might cause some security issue to open some ports. Okay, as this is like a local project, so I don't want to open any other extra port, but you can also open another extra port and just you can use this a quadrant WebUI and access it from access it, create add a domain name, and you can access it from anywhere. Okay, so for my case, I'm accessing it from my local. Okay, so as you can see, this is a collection. So in this collection we have like 146 different type of products. Okay, and there are some specific features of this. Okay, so as you can see here, this vector configuration. Okay, so this vector configuration tell you how this collection is configured. Okay, so this name of this configuration is like default. I did not change anything. Okay, I did not mention a specific name. Okay, now here is the part that we need to consider. Whenever we try to create embedding. Okay, so we have to specify in how many dimensions we need this embedding to be. Okay, so different LLM model provide different embedding dimension. Okay, some provide thousand in the range of thousand, some provide in the in some lower range, and here in this case I'm using the OpenAI LLM. Okay, so its dimension is 1536. Okay, and here is the now let us talk about this distance thing. Okay, so this distance, how the distance, how the similarity will be calculated. There are multiple way you can calculate the similarity. Okay, so here we are using the cosine method. Okay, but you can use also the dot product. Okay, dot product of vectors, and you can also use Manhattan similarity. Okay, so now but here in this case we are using the cosine distance similarity. Okay, so now let us just open and let us show you how these products are distributed, and how certain type of products are close to certain type of products, and how other products are grouped to other similar products. Okay, so let me just visualize here. Okay, okay. So this is our 2D representation of our products, like one entire 146 products that we have. This is the two-dimension representation of close similarity representation of our products. Okay, so now let me just click on. So as you can see here in the right part here, what it say, it is non-mates, bird cage food, and water dispenser. Okay, so this is the product. So this product is related to bird cage and bird cage food dispenser, water dispenser type of product. Okay, so this is the product. So let me just go to so as you can see, this is the product. Okay, this is the product. Okay, and as you can see, there is another product which is really close by to it. Okay, if you just go to here, yes, this product ID is 141 and this product ID is 131. So now let's check that what this 131 product represent. Okay, so this 131 product represent that what its name is, high quality plastic bird cage, water and food feeder. Okay, so both of these products are different products, but they are similar. Okay, this one ID number 131 product is also bird feeder. Okay, and this ID number 141 is also bird feeder. Okay, so let me just try to show you that these two products. Okay, so this is the 141 number products. Okay, and So this is 131 ID product. Okay, so as you can see that both of the products are different, but they are close. As you can see, they are closed, represented using the cosine similarity. Okay, so this is like this is our vector database. Okay, so now I think let me just show you the flow diagram that how the things are happening. Okay, so it will be much more clear. So this is the flow diagram. Okay, let me just. This is the entire flow diagram of it. Like here in this flow diagram, I have only considered two scenario. One is like when someone do product search from the search bar and when someone do product search from the chat bot. Okay, product search or any other query from the chat bot. Okay, so let me just so as you can see, user comes here. Okay, so this is our front end MX. We have multiple microservices services present here. Like this is front end MX. Okay, and so once user comes here, let's say user doing a normal search bar search. Okay, so what it will do, it will go. This query will go to the product microservice. Okay, so this is responsible for searching products. Okay, this product microservice will go to Algolia search and uh, it will try to find any result. Okay, so if there is a result, if there is result, then it will return to the product mix, and if there is no result, it will go to this path. Okay, and it will then it what it will do, it will do embedding of the query that user provided. Okay, so it will generate a vector. Okay, so after doing a representation, it will generate like we are using like 1536 dimension. Okay, so this query will be represented in 1536 dimension. Okay, so after doing the embedding, so a bunch of number will be generated which we call as embedding. Okay, vectors will be generated which we call as embedding, and those vector will go to our vector database, and we will match our embedding vector with in our a vector database. Here in this case we are using self-hosted quadrant. Okay, so after doing a vector database search, okay, so here in this case we I have like mentioned like if the match is like above 80% or something, only return then only return value. Okay, because you have to provide a threshold like how much similarity you have to minimum similarity value you must have to return a product. Okay, so if that similarity is above the threshold, it will return that value to the product mx, and if the similarity is not that much, then it will return empty array to product mx, and product mx will return to front end mx, and it will show that no product is found. Now let's talk about this chatbot part. Okay, now let's say user wants to do chatbot thing. Okay, now this chatbot will this query will handled by message service mx. Okay, so this message service mx will have can have this tab can have these activities this message service mx can perform. Okay, like I told you before, like this message service mx this chatbot can gather customer information like name, email, and phone number, and it can also help with customer login. Like after providing this information, it will send you a OTP over WhatsApp, and it will then you if you validate, then it will like log you in automatically. Okay, so after that there is another feature that I told you, that the customer also can get, after login, customer also can get their own account specific order details. Okay, like order status. Okay, like where is their order and how many days it will take to deliver, this type of thing. And also there is another feature that this chatbot can do, which is search product based on the user query. Okay, like user wants to search, like I showed you like before, that this query user search with. Okay, so if I search with if I add this query to Algolia, Algolia is not returning anything, but in our chatbot it returns some products by doing embedding similarity mapping, and it return the value. Okay, so to gather this customer information, first it also can create and update customer in DB. Like this chatbot can connect to customer microservice. There is another microservice called customer microservice. It can connect to customer microservice and create or update customer information there. Okay, so after that it will do the login and send OTP, and this OTP then it will do OTP validation, like I showed you in the. Sorry guys, the recording time cap exceeded, so it got stopped. Uh, so uh, uh, so now go to this customer order details status fetching. Okay, so if customer like search for query, like I want to know what is the latest status of my product. It can come here, and what this chatbot will do, it will query our order MX. Okay, so as you can see here, the chatbot is dynamically based on user intention. The chatbot is picking different API to call. Okay, so in this case, this customer information gathering and login to and logging the customer. In this case, chatbot is calling the customer MX. But in this case, this order status finding case, the chatbot is calling this order mx. Okay, so once hitting the API, the chatbot will like this API will return like whether a customer have any order, and if it has any order, then it will show the order status, and this information will be passed to a message MX, and this message MX will show customer the information, like their order status. Okay, so if now let us go to this part, this products search query part. Okay, and now if customer search for a product. Okay, customer want to search products under like 50 rupees, 100 rupees. So now what it will happen, so it will go to the product mx, like in the search bar case, the same steps it will do. Okay, so it will go to the product mx, and then it will go to the Algolia. If Algolia is able to like provide the information, then good, it will return to the product mx. And if it is not able to find any information, then it will call, it will do the do embedding for that query, for that user query, and some vectors will this LLM will return some vectors. Okay, and that vector will be matched with our coordinate vector database, and try to find similar result. And as I told you before, that we have a threshold like 80% or something. So if that query matches some products which are similar to above 80% similarity, then it will return. Otherwise it will return empty, and same thing happen, and then this information will be passed to message mx, and message mx will show to like show to the user. Okay, so here is some another part, so I have used here Socket IO to do the real-time communication here. Okay, So this is it. I guess I have covered almost like basic part, everything. Okay, so if you want to know any specific part of this application, you can just ask for it, and I'll try to help you out if I can. Okay, so thank you.